In this video, we are multiplying polynomials. So you might remember that a polynomial is just an expression that has more than one term. So for example, if we had the polynomial a plus b, where a and b can be any terms, and we multiply it by another polynomial, c plus d plus e, where c, d, and e are any terms, then this is a binomial, which is two terms, times a trinomial, which is three terms. So a polynomial, it just means that you have some terms that are separated by addition or subtraction. Now, if we were going to use the box method to multiply these, then the box method just tells you that if you have, for instance, here we have two terms, and we're multiplying it by three terms, then we're going to set up a 2 by 3 box. And that 2 by 3 means 2 rows and 3 columns. So we would set up a box. Doesn't have to be perfect. Just give yourself enough space to write within each of the boxes. So we'd have 2 rows and 3 columns, giving us a total of 6 boxes. Now, in each row, you're going to put the terms from the first polynomial, so a and b. And in the columns, you're going to put the terms from the second polynomial, c, d, and e. And then what happens is you're going to multiply within each column. So you would do a times c, and then a times d, and then a times e. Then you would go to the next row and do b times c, b times d, and b times e. So we're going to do some examples using actual polynomials that you would see. Starting with the first one, we have 3x plus 2 times x plus 4. So this is a binomial times a binomial. So 2 terms times 2 terms, which means we need 2 rows, 2 columns. Okay, now we're going to take the first 2 terms and they go on the rows. Then we take the terms from the second polynomial and they go in the columns. And what we're going to do is we're going to multiply 3x times x. Now I have something to remember. After you set up your box, then you start multiplying within each box. Something to remember is that when you are multiplying variables, so we have 3x times an x, you're going to add the exponents with the same base. So that means our base of x, these both have an exponent of 1 because it's not written. So we're actually going to add x to the first times x to the first. We're going to add 1 plus 1 and get a 2. So that's going to give us 3x squared. Okay, now moving on, we're going to do 3x times 4. So 3 times 4 is 12 times x. Now moving to the second row, we have 2 times x, which is just 2x. And finally, 2 times 4 is just positive 8. Now we are going to combine like terms, but I want you to notice that your like terms typically are going to be in the diagonal. And remember that like terms, when you're combining like terms, you can only add or subtract terms with the same variable and the same exponent. So we have 3x squared, 12x, and 2x, but we can't add all of them together. We can only add the terms that have x to the first power. Right, so if we were to actually split this up, it would be 3x squared plus 12x plus 2x plus 8. Now, if you'll notice, 12x and 2x you can combine. So that gives us 3x squared plus 14x plus 8. and that is our multiplied polynomials. Right, in the next example, now we have 2 terms times 3 terms. So we need a 2 by 3 box. So we need 2 rows, 3 columns. All right, so we're going to take the terms from the first polynomial, 4x and 9, and then take the terms from the second polynomial. Now notice I have a negative 5x, so negative 5x is what's going to go in that box. If it's a negative sign, keep it with that term. All right, now we multiply. So we're going to multiply 4x times each of these. So 4x times 2x squared. 4 times 2 is 8. Then we have x times x squared. And remember, that's going to be adding those exponents. So 8x to the 3rd power. All right, then we have 4x times negative 5x. So 4 times negative 5 is negative 20, and we have x to the 1st power times x to the 1st power, so that's x to the 2nd power. All right, and next we have 4x times 3. 4 times 3 is 12, times x is just 12x. Okay, now moving on to the second row, 9 times 2x squared. 9 times 2 is 18, x squared. 9 times negative 5x, negative 45x. And then 9 times 3 is 27. All right, so if we write this out, notice that our like terms are still in the diagonals. So we have x squared terms here, and we have just plain x terms here. Okay, so we are going to actually go ahead and combine those. So we have 8x to the 3rd power. Now we're going to combine 18x squared minus 20x squared, which is negative 2x squared. Okay, then we're going to do the same thing with the plain old x terms. Negative 45x plus 12x is going to give us negative 33x. Then we have a positive 27. So this is our simplified multiplication of those 2 polynomials. All right, in our next example, we have 2 terms times 2 terms, so we need a 2 by 2 box. Okay. So we have in our first polynomial 3a and negative b. Now remember, this is really like a negative 1b, so I'm going to go ahead and put that negative 1 there just so we can remember that as we multiply. All right, and then we have 2a and positive 4b. Okay, now when we multiply these, 3a times 2a, remember that these have an exponent of 1, and if we're multiplying those same variables, we have to add the exponents. So 3 times 2 is 6, a to the 2nd power. Up next, we have 3a times 4b. 3 times 4 is 12. Then we have a times b. We cannot combine them any other way, so it's just 12ab. moving to the second row, we have 1b times 2a. So negative 1 times 2 is negative 2, and again we just have a times b, or b times a. So you could write b times a, or you can write it in alphabetical order. When you write it in alphabetical order, it's a little bit easier to see that these are going to be like terms. And then finally we have a negative 1b times positive 4b. So negative 1 times 4 is negative 4, and then b to the first power times b to the first power is b to the second power. Now again, we want to combine those like terms that are in the diagonal. So we have 6a squared, then 12ab minus 2ab is still positive 10ab, and then we have negative 4b squared. Okay, and finally in our last example, we have 2 terms times 3 terms, so we need a 2 by 3 box. Right, so we need 2 rows and 3 columns. Okay, in our rows, we have 2b and positive 1. And in our rows, we have 2b plus 1. In our columns, we have b squared, negative 5b, and positive 4. Now we are going to multiply. 2b times b squared. Remember that 2b has an exponent of 1, so we're still multiplying. 2, and we're going to have b to the third power because we're adding those exponents. Then 2b times negative 5b. 2 times negative 5 is negative 10. B to the first power times b to the first power is b to the second power. 2b times 4. 2 times 4 is 8, and b. Moving on to the second row. 1 times b squared is just 1b squared. 1 times negative 5b is negative 5b. And 1 times 4 is 4. Now we want to look at our like terms. So in our diagonals, we can see we have b squareds, and then we have just the plain old b's. All right, so that's 2b to the third power, and now we're simplifying. B squared minus 10b squared. So this is like a 1b squared minus 10, which is negative 9b squared. Then we have negative 5b plus 8b, or 8 minus 5, which is still positive 3b. And then finally we have a positive 4. Now let's talk about area and volume. Areas are calculated by multiplying. So just a couple of common areas that you might be asked to find are the area of a rectangle, which is the length times the width, and the area of a triangle, which is 1/2 the base times the height. Volumes are also found by multiplying. So volumes, the main volume that you may be asked to find is the volume of a rectangular prism, which is the length times width times height. So if you were asked to find the area of this rectangle, with the side lengths x plus 6 and 2x minus 1, you would have to multiply the length times the width. So it doesn't matter which one you assign the length and which one you assign the width, but you are going to multiply them together. So we have x plus 6 times 2x minus 1. Now if we're going to use the box method to do this, this is a 2 by 2. Alright, so I'm going to create my box, a 2 by 2. And in the rows, so on the left side of the box, I'm putting x plus 6. So x and positive 6. Then on the top, I'm putting 2x and negative 1. And we are multiplying within each box. So x times 2x, remember this is like a 1x, so 1 times 2 is 2, and x to the first power times x to the first power is x to the second power. Then we have 1x to the first power times negative 1. So 1 times negative 1 is negative 1, and we still have x to the first power. Then we have 6 times 2x. So 6 times 2 is 12 times x, and 6 times negative 1. Now remember that we have like terms in the diagonal. So when we simplify, that's going to be 2x squared minus 1x plus 12x minus 6. And we can combine those like terms. So 12 minus 1, or negative 1 plus 12, is positive 11. And that is our final answer. We cannot simplify anymore because we don't have any more like terms. All right, which expression represents the area of the rectangle below in square units? So again, we're looking for the area, which is the length times the width. So length, width, and we are multiplying them together. So if we have 2x times 3x plus 2, this is one term by two terms. So we need just a 1 by 2 box. Okay, so we don't have to do any splitting on the left. We just need to split this into 2. So we have our one term is going to go on the left, and then we have our 2 terms that are going to go on top. Right, so we are multiplying within each box. 2x times 3x, so this is kind of like distributing, it's the same idea. 2x times 3x, that would be 6x squared to the second power, because 1 plus 1 is 2. Then 2x times 2 is 4x. Now we can't simplify this anymore, it's just 6x squared plus 4x.